Astronomers around the world are once again turning their attention toward the outer reaches of our cosmic neighborhood as a mysterious visitor approaches Earth next week. And surprisingly, it is not the much-discussed interstellar object 3I/Atlas. Even so, the recent observations of 3I/Atlas have sparked renewed fascination with objects that drift into our solar system from the depths of interstellar space. In late August 2025, a team of scientists and students working with the Gemini South Telescope at Cerro Pachón in Chile captured a remarkable image showing the formation of a growing tail on Comet 3I/Atlas. This comet, discovered on July 1st by the Atlas Survey, short for Asteroid Terrestrial Impact Last Alert System, is only the third known interstellar object ever detected passing through our solar system. Before it came the elongated, cigar-shaped traveler named Oumuamua in 2017, followed by the comet-like Hybrid 2I/Borisov in 2019. Each of these objects has provided astronomers with a rare and valuable glimpse into materials and processes from planetary systems beyond our own. The new image of 3I/Atlas is especially important because it shows the comet actively developing a tail as it approaches the Sun, a sign that the icy materials within it are beginning to sublimate. Sublimation is the process in which solid ice transforms directly into gas without becoming liquid first. This gas escapes from the comet's nucleus and forms a surrounding cloud known as the coma. As solar radiation increases while the comet moves inward, more material escapes, lengthening the tail and making the comet more visually striking. The recently captured images from Gemini South reveal this transformation in real time, offering scientists an extraordinary chance to study an interstellar visitor as it reacts to the conditions of our solar system. Astronomer Karen Meach of the University of Hawaii Institute for Astronomy, who led the observation team, emphasized that this image represents both a scientific achievement and a moment of reflection. According to Meach, interstellar visitors remind us that our solar system is just one small part of a vast, dynamic galaxy, and that even fleeting objects passing through can leave us with valuable insights into distant worlds. Since 3I/Atlas will eventually exit the solar system, just like Oumuamua and 2I/Borisov before it, the time astronomers have to gather information is extremely limited. In the latest image, the wide coma of 3I/Atlas is clearly visible, and the tail stretches across roughly 1/120th of a degree in the night sky. For a visual reference, 1 degree in the sky is about the width of a person's little finger when their arm is fully extended, meaning that even a fraction of a degree represents an impressive span across space. The comet's visible features have grown significantly since previous images, confirming that the comet is actively responding to the sun's heat. Observations like these are more than visually stunning. They contain scientific information that can be extracted from the light emitted by the comet. The wavelengths of this light form a spectrum, which acts like a chemical fingerprint. By studying this spectrum, astronomers can determine what materials make up the comet's coma and tail. Meach explained that the primary goals of these observations were to measure the colors and spectra of the comet. The colors reveal clues about the size and composition of dust particles, while the spectra provide direct information about the chemical makeup of the comet. The team was particularly excited to see how the tail had grown since earlier observations, suggesting that the particle distribution had changed as the comet became more active. For the first time, scientists were also able to extract clear spectral data, giving them their earliest look at the comet's chemical composition. The findings from these observations suggest that 3I/Atlas contains chemicals similar to those found in comets that formed within our own solar system. This is a remarkable discovery because comets preserve ancient material from the early stages of their planetary systems. If 3I/Atlas resembles comets native to our solar system, it implies that the processes that shape the planets and smaller bodies around our sun may be common across many star systems in the galaxy. In other words, the way our solar system formed around 4.6 billion years ago might not be unique. Instead, the same types of conditions and materials could be present around countless other stars, giving astronomers valuable insights into how common planetary formation might be throughout the universe. The Gemini South Telescope is expected to have another chance to capture new data from 3I/Atlas later in November 2025, after the comet emerges from behind the Sun. Researchers are eagerly anticipating this upcoming observation window, as interstellar comets are incredibly rare and offer only brief opportunities for close scientific study before they disappear back into deep space. Bryce Bolin, a research scientist at Eureka Scientific who assisted with the observations, noted that each interstellar comet acts as a messenger from another star system. By examining the colors, light patterns, and chemical signatures in their spectra, scientists can begin to understand the diversity of worlds beyond our own and explore what kinds of environments exist around other stars. Beyond the scientific significance, the observation project also carried an educational and public engagement component. The image was captured in partnership with the Shadow the Scientist initiative, which connects members of the public with real scientific research. Participants were able to witness firsthand the process of tracking an interstellar comet using Gemini South's powerful instruments. This collaboration highlights the importance of not only conducting groundbreaking research, but also sharing it with the wider community to inspire curiosity, learning, and future generations of scientists. The growing interest in 3I/Atlas is part of a broader fascination with interstellar objects, which only recently became detectable with modern technology. Oumuamua, the first known interstellar visitor, puzzled scientists with its unusual shape and unexpected acceleration as it left the solar system. 2 years later, 2I/Borisov provided a clearer example of what a typical interstellar comet might look like, complete with a dusty coma and tails similar to familiar solar system comets. Together, these discoveries revealed that interstellar objects are not as rare as once believed. They likely pass through the solar system on a regular basis, but only recently have surveys become sensitive enough to spot them. The discovery of 3I/Atlas continues this growing chapter of astronomical research. Its activity, chemical makeup, and tail formation are not only fascinating, but also scientifically meaningful. Every piece of information gathered helps scientists build a bigger picture of how planetary systems form and evolve across the galaxy. Because interstellar comets carry material from distant stars, they offer a direct sample of regions we could otherwise never explore. These natural messengers travel unimaginable distances through interstellar space before briefly passing near our Sun, and during that moment, they reveal secrets about the environments they came from. The excitement surrounding the comet's approach is further amplified by the fact that it represents only one of several rare cosmic events unfolding around the same time. While astronomers are tracking other unusual visitors expected next week, the story of 3I/Atlas remains central to ongoing discussions about the origins of planetary systems. Whether an object originates within our solar system or far beyond it, the physical processes triggered by sunlight, such as sublimation and tail formation, remain consistent. These shared characteristics help astronomers compare different types of comets and better understand their life cycles. The approach of 3I/Atlas and the new discoveries it brings demonstrate how rapidly our knowledge of the universe is expanding. Just a decade ago, the idea of regularly detecting interstellar objects seemed nearly impossible. Now, with more sophisticated telescopes, advanced imaging techniques, and global survey programs, the once hidden visitors from other star systems are becoming part of a new era of astronomy. These discoveries not only reshape our scientific understanding, but also invite us to reflect on our place within a much larger cosmic environment. Each time an interstellar comet sweeps past our Sun, it offers a brief but unforgettable reminder of how deeply interconnected the galaxy truly is.